Let's look at blood pressure. This is measured using a sphygmomanometer and a stethoscope. The idea is that you collapse an artery, then you let it refill, and you see how much pressure it takes to reopen that artery. Blood pressure is measured in millimeters of mercury. So you'll notice it says mmHg. That stands for millimeters of mercury. If you have a tube, and at the bottom of the tube you have a bulb, and you put mercury in this bulb. When you squeeze the bulb, that causes the mercury to move up into the tube. You then get a ruler and you place your ruler next to the tube and you see how many millimeters the mercury has moved up. That's how you get your units of measure for blood pressure. The sphygmomanometer is the cuff that goes around the person's arm. This cuff is inflated. As you inflate the cuff, you squeeze the artery and collapse it. Here you can see the collapsed artery. Then you slowly release the pressure. There's a tube that goes from the cuff to your dial. Here's your dial. This dial is telling you your millimeters of mercury. As you release the pressure, the mercury starts falling back down. Your artery is also going to open back up. The pressure in the artery is the greatest during systole, when the heart contracts. So as you release the pressure, at some point, the pressure of the heart pumping is great enough to overcome the pressure of the cuff squeezing. At this point, the artery will reopen and blood enters it. When the blood re-enters the artery, it makes a sound. It's a gurgling sound that you can hear. When you hear that sound, you look at your dial. You see how high the mercury is on your dial at that time. That tells you the pressure in the cuff when the artery reopens. This is your systolic pressure. In an average healthy adult, this would be around 120. Then you continue to release the pressure. You can see here when the blood first re-enters, it's kind of gurgled. It's a turbulent blood flow. As you release pressure, the artery opens all the way. Okay, here you can see the artery fully open. Once the artery is fully open, the blood flow is smooth. You can see you don't have those swirly lines there anymore. It's just nice, smooth blood flow. So the sound you hear from your stethoscope changes once this blood flow smooths out. When you hear that change in sound, you again look at your mercury dial and you see how high up the mercury is. This corresponds to diastole in the heart when the heart is resting. So this is your diastolic pressure. Which in your average healthy adult is about 80. That's how you measure blood pressure. Once you have blood pressure measured, there are a couple of calculations we can make from it. For these calculations, we're going to assume that we have an average healthy adult at rest with a blood pressure of 120/80. The first measurement, or the first calculation that we want to take from this is pulse pressure. This picture shows an artery when it's in systole and when it's in diastole. This top picture shows the systole. This is when the ventricles contract and push blood into the arteries. The arteries have to expand to accept this pulse of blood from the heart. The bottom picture shows diastole, when the heart is relaxed and refilling with blood between beats. During diastole, the artery rebounds. It recoils back to its original. Pulse pressure is the difference between these. It's how much change you have during systole. To calculate pulse pressure, you simply subtract. You take your 120 minus 80. And in this case, it's 40. So a typical pulse pressure is about 40. This indicates how well your arteries expand. Healthy arteries are elastic. So they can expand to receive that pulse of blood from the heart. If arteries are hardened, then they won't expand to receive that pulse of blood. So knowing someone's pulse pressure gives you an idea of the elasticity and health of their arteries. The other calculation that we want to look at is mean arterial pressure, which is abbreviated MAP. Think back to math classes you've had. Mean means average. So MAP is the average pressure in your arteries. Okay, think about what you learned about the cardiac cycle. You have the entire heart in diastole. This is when the heart relaxes to refill. Then you have atrial systole. During this time, the atria contract while the ventricles remain relaxed. Then you have ventricular systole. The ventricles contract. This is when you push that pulse of blood into the arteries. During these two steps, diastole and atrial systole, you have your diastolic pressure. Which would be our 80. During this time, you have your systolic pressure. Which would be our 120. So only 1/3 of the time you're in systolic pressure. So the formula for calculating MAP has to take into account that you only spend 1/3 of your time in systolic pressure. You also don't want to count systolic pressure twice. So to find the MAP, you take your diastolic pressure and you add 1/3 of your pulse pressure. Okay, the 1/3 is because you only spend 1/3 of the time in systolic, and the reason you're using pulse pressure is because that's the increase that you get during systolic. So if we have a typical person with a blood pressure of 120/80, MAP would be 80, the diastolic, plus 1/3 of 40. That's your pulse pressure. This works out to 93. So 93 is a typical mean arterial pressure. MAP is important because it indicates perfusion. As long as you have a good healthy MAP number, you know that you are getting enough blood to your tissues to meet their needs. As long as your MAP is between 70 and 110, you will have adequate perfusion to your tissues. A MAP that is too low indicates that you are not getting enough blood to your tissues. So it indicates poor perfusion. This means that you will not pick up waste, so your cells will be building up in their own waste. It means you're not getting enough oxygen and nutrients to your cells. And it means that your kidneys can't adequately filter your blood and your blood will start to become toxic. Because you rely on an adequate MAP in order to push blood through the kidneys. If MAP is too high, you can also get problems. This means that the pressure in your capillaries is too high. So remember from an earlier lesson that the pressure, the hydrostatic pressure in capillaries should be about 35. If your MAP is higher, then you will have higher pressure in your capillaries. This means you will push more water out of your blood. This will give you edema. You'll be pushing too much water out of your blood and it will collect in your tissues.